The fourth example in the series of time rates is solved a little longer than the previous problems. Check it out here in differential calculus. The container to be filled this time is a triangular trough having a length of 10 feet, width of 4 feet across the top, and 4 feet height. Water flows in at a rate of 3 cubic feet per minute, and we are to determine how fast the surface is rising when the water is 6 inches deep. Illustrate the triangular trough, which is filled by water at a rate of 3 cubic feet per minute. The trough has 4 feet width across the top, and its length is 10 feet. It is also 4 feet deep. Additional data of 3 feet cube per minute is provided. This is the change in volume with respect to time. The volume of a triangular prism is the cross-sectional area, which is a triangle, multiplied by the length. V is then half of the base times the height multiplied by the length. The length is constant at 10 feet as water is distributed to the whole length as it flows. The volume then is half of base times height times 10, which is simplified as 5 times b with h. The function contains 3 variables, v, b, and h. So we need to find correlations to reduce the number of unknowns. To correlate b and h, we use similar triangles. The triangles to be compared are the smaller one, which represents the rise of the surface of water. The height is denoted as h, and the base is b. This triangle is compared to the bigger one, which represents the trough when it is full. The trough then has a base of 4 feet and depth of 4 feet. With ratio and proportionality, the base b, or the smaller triangle, is to 4 feet base of the bigger triangle. This is equated to the height h of the smaller triangle to the height of the bigger triangle, which is 4. The proportion shows that b is equal to h. So from the volume function of 5bh, where b is the same as h, the volume v becomes 5h squared. Now we have two variables in the equation, so we are ready to differentiate. dv over dt is then 5 times the derivative of h squared, which is 2h. Then through chain rule, there is dh all over dt. Since we are looking for dh over dt and dv over dt is also provided, we still have to identify h, which is by the way also provided in the premise. H is given as 6 inches or 0.5 foot. Plug all the values in the function to have 3 as equal to 5 times 2 times 0.5 by dh over dt. dh over dt is then simplified as 3/5, which is then 0.6 feet per minute.